Kayla Golden. I'm a third-year student here at UW-Platteville. I'm studying electrical engineering, and currently I'm doing research with Dr. Evensen to fabricate a carbon nanotube vacuum channel field emission transistor. We typically just call it a VFET for short.
So what I've got here is the transistor that Kayla is working on, the VFET. And so this is a piece of silicon, and on there are two little golden butterfly patterns, I think of it. Each of those patterns consists of 5 transistors. And so the process takes several steps.
I think the coolest thing about working on this project is just the fact that I get to be in the Nano Lab. In terms of like getting trained on all the equipment here, because obviously none of it's really intuitive, so you need to be taught how to use it, and it seems overwhelming and intimidating, but you come in here and people are really nice and definitely willing to help you out. When I'm making this device, I start by using the spin coater, and what we do with that is we're able to vacuum seal a sample down onto a disc. Once the carbon nanotube is deposited, I come over here to the AFM, which is behind me, and I use that to look at the carbon nanotubes because, like I said, they're so small, there's no way I could even see them with a regular microscope like you would use in your science class. The first major step after depositing carbon nanotubes is to go to the Scanning Electron Microscope, which we call the SEM for short. And this SEM is going to help me also look at things that are very small, although it can't see carbon nanotubes, so it doesn't go quite as small as the Atomic Force Microscope, but it can see my device, which is a couple hundred nanometers. Once I do E-beam lithography in the SEM, I go over to the sputter coater, and this sputter coater is used to sputter down that gold that I was talking about. At that point, I basically have a carbon nanotube transistor built, and then once that's finished, I can take it back to the probe station and test my final device, which is the VFET. One thing I really like about doing research at Platteville versus somewhere else is that I can come in here almost any time of the day, use any equipment I want as long as no one else is using it, which usually there's not, because this is a smaller school, and so you have a lot more accessibility to the equipment and working in here, and I think that's super awesome.